Hello students, today we are going to learn Coulomb's law. So if you see in the here, what is this? It is nothing but a question asked in a Karnataka physics. I'm a lecturer in physics in Karnataka state. So this question is repeatedly asked for these 3 years and for these 2 years, 2 marks and 1 marks. So that's why I have mentioned in my notes the question is repeatedly asked in which year. Now let's see what Coulomb's law states. So Coulomb's law is about the force of attraction and force of repulsion. Where it comes. So the Coulomb studied this electric charge and he found that there are two types of charges. So one is positive and another is negative. So also he learned that, or he said that if there are same kind of charges, they repel each other, like positive and negative like charges repel each other. If there is a one is positive another is negative, then there is a attraction force. So these two attract each other. So these repel with some force, these two attract with some force. So what is force? By how much it attracts, by how much it repels. That's what Coulomb stated. So according to Coulomb, he said that the force of attraction or repulsion, force of attraction or repulsion between 2 point charges to point charges. I have explained about the point charges. You can refer to the previous videos. It's in my, you can view on my channel link is in description. 2 point charges. Now these 2 point charges must be at rest. At this is the condition. Now, when the 2 point charges at rest exert force or attract or repel each other with a force F which is directly proportional to the magnitude of charges, product of magnitude of charges, and inversely proportional to square of the distance between them. Now these two charges exert or attract or repel each other depend on the situation. If there are like charges, they will repel each other. If there are unlike charges, they will attract. Now this force of attraction or repulsion between these two charges is directly proportional to product of magnitude of charges and inversely proportional to the square of the distance between them. So writing all together, we get this equation. Now r square. Meaning is that suppose there are two charges q1 and another charge may be positive or negative. We will choose negative for to explain this magnitude. Now the force between these 2 point charges is directly proportional to the product of magnitude. Why magnitude? Why magnitude only? Because the force is a vector quantity. Force is vector quantity. And if the charge is negative, suppose any one charge is negative, for example q2 if it is negative, and if we use negative sign here in multiplication, for example, if we consider this force is directly proportional to product of charges, so q is being a negative, uh, inversely proportional to square, what will happen? The force will become negative, but which is not true. Why it is not true? Because negative sign of a some scalar quantity does not define the direction of a force. So that's why you cannot take negative. To avoid negative, we must put this in a modulus. So what will happen? This modulus will remove the negative sign and keep its only magnitude. That's why the force is directly proportional to the product means multiplication of magnitude of two charges and inversely proportional to the square of the distance between them. Now the distance must be from the center to center. As the charge is point charge, also the charge can be spherical. For example, if the sphere there is a charges are stored on a sphere and this sphere on the surface there are charges being stored. This surface sphere can act as a single point charge with total charge. That's why the distance must be important. Now, this is special case we will learn at the end of this topic. Okay, so the distance must be from the center to center because its magnitude is its value from the center. Now, this force is called centric force. Centric force, it obeys inverse square law because square law. I will explain. Now, center to center, that is a distance. Now, this force exerted by Q1 on Q2 is in this direction and that is F12. And if the force exerted by Q2 is also in the same direction if both are positive charges like this. F21, that is second force. Now, the force, if you see, the force is acting along the line joining. So the force is not in this direction, nor in this direction, or nor in this direction. It is only on the line of joining the two charges. So there are few points you need to remember about this force when the law is explained. What are those? So once again I will repeat. So first thing, the force is a centric force. So force starts from center to center, center to center of a charge. Secondly, force, this law obey which law? Inverse square law. This law obey inverse square law, centric force. Okay, so the force act along which line? Along line of joining 2 point charges. So these are the 4 points you need to remember. This law obey inverse square law. The force acts along the line joining the 2 point charges. The force is centric force. So what do you mean by inverse square law? So when it says there is a relation between two terms, one term is inversely proportional to another. In this case, the one term can be 0 if the another term is at infinity, but in this case it doesn't. For example, the force between two charges is maximum when they are very close to each other. If the force between the two charges is not a 0, even if the distance is infinity, it has some value. This is inverse square law, helps here. So this is smallest distance closest to 0. This is largest distance near almost infinity, but the force is not 0 or infinite. So this says inverse square law. Okay. So let's see the statement, what you can write and how can you achieve 1 marks here. Coulomb's law states that electrostatic force of attraction or repulsion between any 2 point charges at rest is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them and acted along the line joining two charges. For Karnataka students, you must write this statement exact. At the end of the statement, you must mention the line joining two charges. Okay. So next explanation, whatever I explained, it is here. Now, Force is proportional, inversely proportional. Okay. Now here the proportionality constant F is proportional to product of magnitude of two charges sine inversely proportional to square of the distance. Now this proportionality, when we convert it in equal, there is the absence of some constant value. Then only it will be it will become equal. So this constant value which is absent to maintain equality is called constant, and this constant is called proportionality constant. In this case, this proportionality constant is a small k. I'm highlighting this as a small k because k is going to repeat in next with few minutes. That k and this k is different. Okay, so this k is found to be 1 by 4 pi epsilon naught, which is approximately equal to 9 into 10 raised to plus 9. This is a k value. So ultimately the force equation becomes F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by distance square. Remember, even if I didn't mention modulus, you must consider that is a modulus. Okay, so this is k is proportional to constant and is found to be this value. Now k also comes with one term which is this. This is epsilon, which also comes with 0. Epsilon naught or 0 represents a standard value. Standard value. This epsilon has a standard value of a standard. What is epsilon first? Epsilon is a permittivity. What do you mean by permittivity? So meaning of the permittivity is the permittivity definition little different, but meaning is this is the permission given by the medium, is the permission given by the medium to the electric charges. You can exist in this medium with this much amount of value, and that is for standard medium. That is standard medium is who? Usually air, space, vacuum, all are having same value at epsilon naught is equal to 8.854 into 10 raised to minus 12. So this is the epsilon naught value. Permittivity of free space or any medium. So force is its unit is Newton. Now we will move to the next slide. So let's learn what is permittivity. As I explained, permittivity is a permission given. It's a meaning. But definition is this. It is the property of medium. Yes, of course, it is permission means property of a medium or a material that varies the electrostatic force between two charges. So that changes the force. How it changes, we will learn in few minutes. If Q1 and Q2 are there are 2 point charges placed in vacuum at a distance r, then by Coulomb's law, we know the Coulomb's law at in vacuum or air. So if the same charges instead of vacuum or air, we replace the medium with the permittivity epsilon m, what will happen? Let's see. Everything is same, only medium is changed. Now the force becomes this. Now to find what is epsilon m or how these are related, we have to divide f naught divided by fm. Why f naught by fm? You will learn equation, we get f naught. When you divide this f naught by fm, you will see epsilon m divided by epsilon m, epsilon naught. How? Suppose if you divide f naught divided by fm, you will see 1 by 4 pi epsilon naught into q1 q2 divided by distance square divided by 1 by 4 pi epsilon m q2 q1 q2 divided by distance square. This term is completely same, will cancel out. 1 by 4 pi 1 by 4 pi will cancel out. What is remain? F naught by fm is equal to 1 by epsilon naught divided by 1 by epsilon m. So this is denominator as denominator. So what will happen? This denominator goes to numerator epsilon m divided by epsilon naught. So this ratio is called relative permittivity, and it is this represented like this. So this is a small mistake, it should be capital K. Now epsilon r is a relative permittivity. What is relative? Relative means usually we relate something with someone with standard value. So that's what we are relating, epsilon m divided by epsilon naught. We are comparing epsilon m value with standard median value, and that is what we call relation. This relation is always ends with unitless or dimensionless. Epsilon r is equal to relative permittivity of, and this term is unitless or dimensionless. So meaning of this is this term is just a value which is epsilon r, and this is a capital K. So capital K or epsilon r have different names. Epsilon r is called relative permittivity, and K is called dielectric constant. So as I said, this K is a small k which is proportionally constant. This K is capital K, this K is capital K, which is called dielectric constant. What is a dielectric constant? We will learn in the next class. So before that, please remember this: dielectric constant K is capital K, small k is proportional constant which is small. So this is permittivity and relative permittivity of a medium. As I said, you will understand why we should divide F naught by Fm, because if you see this ratio says epsilon m divided by epsilon naught is always greater than 1. How and why? Because if this is smaller, then if epsilon naught is the standard medium value in which permittivity is the smallest value of a permittivity, and if you want to divide a smallest value by large value, you will get further small value. So to avoid a smaller value, we should take ratios such that like this: 2 divided by 1, 4 divided by 2, or 4 divided by 3, or 3 divided by 2, to avoid further smaller value. So that's why they have chosen larger divided by smaller. If epsilon m value is larger, k is larger, this is larger, but this becomes smaller, fm becomes smaller. So the force in a vacuum medium is always larger. Force in which medium? In other medium is always smaller. So f naught, if you see this formula once again, what you will see? If you see here, relative permittivity, if you see your k equal to, what do you get? Capital K is equal to, what you will get is capital K is equal to epsilon m divided by epsilon naught. So what you will get here? Epsilon m is equal to epsilon naught into k. So this means the permittivity of a free space, permittivity of a medium is larger than the free space is always, and if it is larger, force becomes smaller. If this becomes larger, force becomes smaller. Okay, I hope you understood this all permittivity and Coulomb's law. Thank you for today's class. See you in next video.